Your Databricks bill did not randomly jump 10x. Something is silently multiplying your compute. Imagine opening your cloud bill and seeing this. Last month, around $2,800. This month, more than $28,000. That is almost a 10x jump. And the first mistake is blaming only one Spark job. Look at the real suspects. Jobs plus SQL dashboards. Hidden causes like data movement, small files, idle resources, dashboard refresh storms, and SQL queries scanning too much data. Then the cluster starts scaling out of control. More workers, more concurrency, more compute. So don't just ask, how do I make the cluster smaller? Ask, where is the cost really coming from? More data moved, more jobs executed, more dashboards refreshed. 10x higher cost. Fix the root cause, not the symptom. Here's what makes this so confusing. Same code, same data, same dashboard. So why did the bill explode? Start with the first box, more dashboard refreshes or just more queries running. That pushes the system into the second step, a bigger SQL warehouse or heavier compute to handle the load. Then comes the third problem, slower queries under load. More contention, more queuing, and more complex work happening at the same time. And that leads to the fourth box, a higher bill, because now compute stays active longer and more SQL work keeps running. Look at the silent drivers below. Idle SQL warehouses, always on compute, frequent dashboard refreshes, and full table scans. So the real cost spike is usually not a pricing change. It's compute uptime plus repeated SQL work. Something is silently multiplying your costs. These are the 5 silent cost multipliers that quietly blow up Databricks bills. Number 1, shuffle. That is expensive data movement across the cluster. Number 2, repartition. It can help or hurt depending on how you use it. Number 3, skew. Skew creates stragglers. One task gets too much work while the rest wait. Number 4, small files. They create slow reads and more metadata overhead. And number 5, dashboard refreshes and SQL cost. Frequent refreshes, idle warehouses, and full scans can keep compute burning in the background. Each one may look small by itself, but put all 5 together, and that is how a normal Databricks bill turns into a 10x cost. Small inefficiencies, massive impact. Now let's start with number 1, shuffle. Shuffle means expensive data movement. Look at the left side. Shuffle is common in joins, group by, and sort operations because Spark needs to redistribute data across the cluster. That redistribution is where the cost starts. First, Shuffle moves data across the network. Then, it can add disk I/O and time because data may be written locally and read back again during execution. And this can also make SQL dashboard queries more expensive, especially when dashboards trigger the same heavy data movement again and again. Now look at the center. Data from stage N gets redistributed into stage N plus 1. That means each partition can be sent to multiple executors, so the more data moved, the higher the cost. Then look at the Spark UI on the right. If you see high shuffle read and high shuffle write, that is a warning sign. This stage is moving a lot of data, and that usually means a high bill. So the takeaway is simple. Shuffle equals high network traffic, high disk I/O, and high cost. Now let's move to number 2, repartition. Repartition can help or hurt. The number of partitions you choose can make or break performance. Start on the left red panel. Too many partitions means overhead. Spark creates too many tiny tasks. That causes high scheduling and coordination overhead. You may end up with thousands of tiny tasks where Spark spends more time managing work than doing useful work. And the result is slower dashboards and slower jobs. Now look at the right red panel. Too few partitions means giant, slow tasks. The cluster has poor parallelism. There are too few tasks to use the full cluster capacity. Some tasks run for a long time and your dashboards and jobs slow down again. Now look at the green panel in the center. This is the sweet spot. Right-sized partitions, balanced task sizes, efficient resource utilization, good parallelism, faster dashboards and jobs. So the goal is not more partitions or fewer partitions. The goal is the right number of partitions based on data size, cluster size, and workload. Too many partitions create overhead. Too few partitions create slow tasks. Right-sized partitions lower cost. Now let's move to number 3, skew. Skew creates stragglers. Start on the left side. First, one key has too much data. That means one partition is holding most of the data. Second, many tasks finish quickly. Most partitions complete early, so the cluster looks like it is almost done. But then comes the painful part. Third, one task runs much longer. That slow task holds up the entire job. Now look at the timeline in the center. The green tasks finish early, but the long red task keeps running until the end. That is the straggler. And the straggler delays everything. Longer job duration, more retries, more compute time, higher cost. This also affects dashboards and BI queries. Hot partitions can delay SQL dashboard tiles and reports for everyone. So when you see one long red task in Spark UI, don't ignore it. That is not just a slow task. That is your money waiting. Now let's move to number 4. Small files destroy performance. Too many tiny files create massive overhead and slow everything down. It starts with thousands of tiny files inside the data lake or lakehouse. Then Spark and SQL engines need to read more file metadata. More metadata means more planning. More planning means slower queries. And slower queries mean higher cost. This is why small files are dangerous. They don't always break your pipeline. They quietly make every read more expensive. And the pain is not only in batch jobs. Small files also hurt SQL dashboards and BI queries. More planning, slower dashboards, higher latency, poor user experience, more compute, higher BI costs. The fix is to optimize and compact. Instead of thousands of tiny files, create fewer, larger, better organized files. When it fits your workload, use compaction, optimize, and liquid clustering to improve file layout and query performance. The goal is simple: fewer files, lower metadata, smarter planning, faster queries, lower compute cost. Small files look harmless, but at scale, they silently burn your budget. Now let's move to number 5. Dashboard and SQL costs you ignore. This is the part many data engineers miss. Your Databricks bill is not only Spark jobs. SQL dashboards can become a serious cost driver. First, idle SQL warehouses. Compute may be running when no one is using it. Second, frequent dashboard refresh. Every 5 minutes sounds harmless, but every refresh can wake up compute and run more SQL again. Third, full table scans. No partitioning, no liquid clustering, or poor filtering can force queries to scan everything. And fourth, high concurrency. Many users hitting the same warehouse can create more pressure, longer duration, and slower dashboards. That is why query history matters. Look for query duration, rows read, data scanned, and query source. If you see dashboards scanning hundreds of gigabytes again and again, the problem is not only your ETL layer. The SQL dashboard layer is burning compute too. Use query history to find expensive queries and heavy dashboards before they quietly multiply your cost. Now the important question: how do you cut Databricks cost fast? Use this money-saving playbook. First, enable auto-scaling and auto-termination for all clusters. Do not let compute run when nobody is using it. Second, right-size your SQL warehouses and set auto-stop. A bigger SQL warehouse is not always better. Sometimes it only makes inefficient queries more expensive. Third, optimize your queries. Filter early. Avoid unnecessary full scans. Use partitions or liquid clustering when they match your query patterns. Fourth, reduce dashboard refresh frequency. Not every dashboard needs to refresh every 5 minutes. Every refresh can become another query, another warehouse wake-up, another compute charge. Fifth, compact small files. Use optimize when appropriate. Use Zorter or layout strategies only when they fit your workload. And sixth, monitor with system.billing.usage and enforce policies. This is how you stop guessing. Track cost by jobs, by SQL, by users, by workspaces. Use system tables to track every dollar. Find where the DBUs are going. Then fix the correct layer. Not everything is a Spark problem. Not everything is a dashboard problem. Measure first, optimize second, control today, save 10x tomorrow. If this helped you understand why Databricks costs explode, subscribe for more real-world data engineering, Databricks, Spark, and cloud cost-saving tips.